Section 7.4, multiple angle formulas. This is not called multiple angle formulas because we are going to be dealing with problems that have multiple angles, but rather because there are in this section angle formulas and there's multiple of them. So we're going to start off with the double angle formulas. And unfortunately, since we're not in class and it's a little bit difficult to kind of go through where you might use these and talk about where they're derived from, we're just going to jump in and use them. So section 4, section 5, and section 6 of this chapter, a lot of what these videos are going to be is just recognizing the structure of these formulas and being able to apply them depending on what the problem is asking. Let's start with number 1. Prove or verify the sine of 2u equals 2 sine u cosine u. So it's basically asking us to prove the first of the double angle formulas. We're going to start by rewriting, instead of sine of 2u, write this as sine of u plus u. And you'll remember before we had the formula that there was sine of u plus v, and we can rewrite this as the sine u cosine u plus cosine u sine u. Well, then if you notice, sine u cosine u, and if we rewrote this, we would have sine u cosine u, so what we actually have is 2 sine u cosine u, which is what we were supposed to prove. Number 2, if the sine of alpha is 4/5 and alpha is an acute angle, find the exact values of the sine of 2 alpha and the sine of cosine of 2 alpha. Now, just because we're doubling the angle doesn't mean we can just double what the sine of alpha is equal to. So we're going to, again, need to write this using the double angle formula. So let's start doing that. And this is going to be the 2 times the sine of alpha cosine of alpha. Well, we know what the sine of alpha is, but we're going to need to draw our triangle to figure out what the cosine of alpha is. So if I draw my alpha, sine is opposite over hypotenuse, and I'm going to recognize that this is from a standard 3, 4, 5 triangle. So now I have 2, the sine of alpha is 4/5, and the cosine of alpha, adjacent over hypotenuse, is 3/5. When I multiply all these together, 2 times 4 times 3 is 24, 5 times 5 is 25. So the sine of 2 alpha is 24/25. Now, when I take a look at the cosine of 2 alpha, I can see from all my formulas up here, I have 3 to choose from. And it really doesn't matter which one we use. So I just went ahead and picked the first one. So I rewrote this, first of all, as cosine squared alpha minus sine squared alpha. And then again, looking at my triangle, the cosine is 3/5, so 3/5 squared minus the sine is 4/5, so minus 4/5 squared. Squaring each of those, 9/5 minus 26, or 9/5 minus 16/5, give us that the cosine of 2 alpha is negative 7/25. Number 3, express cosine of 3 theta in terms of the cosine of theta. So they basically want us to just break apart that 3 theta. And unfortunately, we can't just write this as the cosine of theta plus the cosine of theta plus the cosine of theta. But we can get creative and write this as the cosine of 2 theta plus theta. So first of all, again, we're going to use the sum formula that we learned the other day, which tells us we can write this as the cosine of 2 theta cosine theta minus sine 2 theta sine of theta. And now we're going to use those functions up there, those formulas up above. And it wants us to write this in terms of cosine theta alone. So that means I'm going to use the bottom one for this cosine of 2 theta. So this cosine of 2 theta I'm going to write as 2 cosine squared theta minus 1 times that cosine of theta. Minus, and then sine of 2 theta, I only have one choice, is 2 sine theta cosine theta. And then I still have that sine theta. I'm going to distribute here 2 cosine cubed theta minus the cosine of theta. And I'm going to multiply these two sine thetas. This is just 3 things being multiplied together, so I have 2 sine squared theta cosine theta. I'm getting there. I don't have any coefficients in front of my theta anymore. And now hopefully you recognize that we can use a Pythagorean identity. So I'm going to rewrite this first part, and then I'm going to use the Pythagorean identity. I'd like you to pause the video and just do the distributing and combine your like terms and see what you come up with. I just want to point out, when you are simplifying over here, you're distributing the 2 in, you're also distributing that cosine of theta in. Hopefully you got 4 cosine cubed of theta minus 3 cosine of theta. Next up we have our half angle identities. So there's 3 of those, 1 for sine, 1 for cosine, and 1 for tangent. So we're going to start off by verifying that the sine squared of x times the cosine squared of x equals 1/8 1 minus cosine of 4x. So to begin with, I'd like you to pause the video and rewrite the left-hand side using those identities above. And next we can just multiply them together, multiply numerator by numerator. Hopefully you recognize that on the numerators you have a difference of perfect squares. So you should have ended up with this. And now I want you to pause the video and try to apply this cosine half angle identity to this cosine squared of 2u. And I want you to be careful because we have a u here, but we're using a 2u there. I also made a little correction there because our problem is in x's, and because the formulas had u's, I had changed them all to u's. I've now changed them all back to x's. But what we have in pink here is basically your cosine squared of 2x using that formula. Now we can't have a compound fraction, so I'd like you to pause the video and get rid of your compound fraction. When we multiply top and bottom by that denominator of 2 to get rid of it, we're distributing that 2 over there. And then remember, we're subtracting this whole fraction, so we also need to distribute that negative. Those 2's are going to cancel, but we need to distribute that negative. I'll go ahead and combine your like terms on your numerator, and we have verified that identity. Next, express the cosine to the 4th in terms of the cosine function with an exponent of 1. So again, we're going to start off with that half angle identity. Go ahead and pause the video and see if you can do that. I want to remind you that we can write cosine to the 4th of t like that, or cosine t to the 4th. With that in mind, we can rewrite cosine to the 4th of t like this, and now it's going to be much easier to use that formula up above. That first step is straight substitution. Now I'd like you to square the numerator and square the denominator. And you should get that. And I again corrected myself because we're actually dealing with t's in the problem. Now again, we've gotten rid of the cosine to the 4th, now we need to get rid of that cosine squared. So again, use that identity above, making that other substitution. And I also caught myself, I squared the numerator before, but I had forgotten to square my denominator, so that 2 squared should have been 4. Making that substitution from this step here. Now again, I'd like you to go ahead and get rid of that denominator of 2, or get rid of that complex fraction. Getting rid of your complex fraction. Final step, just combine your like terms and simplify it. And you can have your answer in either one of those forms. And finally, our half angle formulas. Again, this is a matter of recognizing the structure or when to use them. So number 1, the sine of 22.5, if we want to find an exact value, basically when it says you want to find an exact value, that tells you you're going to be using your unit circle. So 22.5 isn't on there, but I could rewrite this as 45 over 2. One thing that you need to recognize here is the sine of 22.5 degrees, that's going to be in the first quadrant, which means my sine is going to be positive. When I come up and look at this formula, that tells me I'm going to be using the positive square root. So I'd like you to pause the video and go ahead and use that formula. Just using straight substitution, you should have gotten that, and now you're going to just use the unit circle to finish this out. But now we have a fraction within a fraction, so please take care of that. And then I can actually take the square root of 4, so there's only one more step left to simplify this. And that's what we get. Next, the 5 pi over 8. I hope you recognize that 5 pi over 8 is half of 5 pi over 4, so I could rewrite this using 5 pi over 4 divided by 2 would give me my 5 pi over 8. Now again, you're just going to use that formula. However, first of all, recognize that 5 pi over 8, Well, 4 pi over 8 would be pi over 2, so half a pi, and that would be right here. So 5 pi over 8 is going to be in the second quadrant, and in the second quadrant the cosine is negative. So when I look at that formula above, I need to make sure that I'm going to use the negative square root this time. So that's going to be 1 plus the cosine of 5 pi over 4 over 2. And again, I'd like you to pause the video and finish this problem. The cosine of 5 pi over 4 is a negative square root of 2, so that's why my sign changed. And again, get rid of your complex fraction, please. And again, I can take care of that 4 on the denominator of that square root. So one more step to simplifying this. And that's what you should have gotten for that. Now, if the tangent of beta is negative 4/3 and beta is in quadrant 4, find the tangent of beta divided by 2. Well, beta divided by 2, any of these half-angle formulas involve the sine and the cosine. So I'm going to have to draw a triangle anyway. So I'm going to start off by drawing my triangle in the fourth quadrant. So if this is my beta, tangent is opposite over adjacent. So opposite is the 4 over 3. And if this is in the fourth quadrant, that 4 is the one that's going to be negative. Now I've got the tangent of beta over 2. Well, which formula should I use? It really doesn't matter, so I particularly don't care for using square roots if I don't have to. I'm going to randomly pick the one that is the sine of beta over 1 plus the cosine of beta. And now it's a matter of filling in those values. The sine of beta, I'm going to refer to my triangle. I need the opposite over hypotenuse. Well, this is a 3/4, so this is going to be a 5 for my hypotenuse. So the sine of beta is opposite over hypotenuse, negative 4 over 5, over 1 plus the cosine is going to be 3 over 5. So negative 4/5 over 1 plus 3/5 is 8/5. If I multiply top and bottom by the 5, I get that this is negative 4/8, which simplifies to negative 1/2. If you have any questions on this, please make sure you come to class. This video has covered very slight applications of those 3 types of formulas. There's going to be one more shorter video that's going to go over the 2 extra examples that uses them again.